Hello and welcome to C3 Streamland. So by now we have seen different types of congruences criterias for the triangles. So one of them is we compare three sides SSS, or we compare two sides and an angle between them SAS, or we compare two angles and a side between them ASA, or we compare two angles and other side that is not between these two angles AAA AAS congruence. And we have seen the right hand side, or the hypotenuse and base congruence for the right angle triangle. Now this in this video we are going to see which congruence doesn't work. So we have done many combinations, but what if we have the values for two sides and value for an angle which is not between them? Then in that case we can say that these two triangles are congruent, right? But as you can see on the screen, angle ABC, triangle ABC and triangle XYZ, both of them look congruent. Both sides, side AB is congruent to side XY, side BC is congruent to side YZ, and there is an angle of 45 degrees. And visually, we can see that these two triangles can be congruent. But there is a very small possibility that one of the triangles might not be a triangle at all. Like as you see, if I move the slider in triangle ABC, this might not be the triangle at all. This can be just a segment with radius 2.5, and here the measures of the sides and angle are still same, but now you can see that one of them is not a triangle, right? So doing the congruency test based on two sides and not an angle between them is not a foolproof criteria. It is possible to create two different figures with the same values, as you can see, right? So we can't say that SSA is a congruence test, right? I just wanted to show this small GeoGebra animation to show you can challenge your existing congruence criteria. Based on this, you can create this simulation in GeoGebra for the rest of the congruence tests, like side angle side, and see if it is foolproof. Can you create two separate figures based on these three values, right? If you can, then you have just challenged the congruency criteria itself, right? And which is a good thing because it's good to question. But if it is not, that means they are foolproof and you can use them in future, right? So I highly encourage you to challenge the existing congruence criteria that we just learned, and try to see if you can create simulations which might allow you to create two separate figures give based on the same values that are given, right? So I hope uh, this triggers you